We are still busy in our series where we are basically recapping a lot of the content that we've covered throughout the semester, and we're doing this in while working through one of the past papers. Okay, so and we're doing this on the VPL system because that's what you're going to have to use during the semester test 2 and the exam. But before we continue, just a few, I think, important announcements. The first is this Friday, you have the prac that is due. Secondly, you also have a very important VPL exercise, or rather a semester test 2 exercise that tries to explain exactly how you're going to submit things on the VPL as well as on EVE. So please, we've sent out a mass email to everybody on Friday, but we have also put a notice of this on both Blackboard and EVE, so there should be no reason why you should not be aware of the semester test 2 practice exercise that you have to complete before Friday. Please note, it is so important that you have to do this that we are considering not allowing people to write the semester test 2 if you have not been successfully doing this, because we don't want to get into a situation where you're going to write the semester test 2 and you've never worked on the VPL. You don't know how to submit things on the VPL. You don't know how to create a backup copy of things that you've created on the VPL. So we want to ensure that everybody at least have that experience before they even try to start to write the semester test 2. Okay, so that's the first thing. Second thing, obviously, prac 8 is due this Friday, and yes, there will be one other prac, and that will be due the Friday after the semester test itself. Then there is another thing which I wanted to mention. Oh yes, if you cannot write the semester test 2 and you have a valid reason for that, you have to apply to write the semester test remotely. The cutoff date for that is also or have been communicated in the mass email that was sent to everybody. So please make sure that for those that cannot write the semester, it's impossible for them to write the semester test 2 on campus, that you actually do apply. If you are going to write the semester test remotely, please take note that we will communicate with you at a later stage, because there are some special requirements that you're going to have to ensure that you abide with while you are writing the semester test. Those things are special software that you will have to install to ensure that you are not cheating and you don't get undue advantage to other students. All right, so let's go through the actual questions that's currently in the chat. Good afternoon, good afternoon, good evening. Must we do the design for the practice? No, there's no design. Please just follow the instructions that's in the practice. There's no design. How will online be conducted, sir? Exactly the same as on campus, but we will implement certain Proctorio software, most likely, to ensure that you are not cheating, meaning you don't have anything else open except the specific website, perhaps maybe code blocks, and that is it, and that your environment and your room that you're working in is in a very good condition. So what is the S student in VPL? Well, Mr. or Mrs. Cello, I would assume that you can maybe interpret S student as the one being the initial and one being the last name. So please go ahead and just change that to your initial and your last name. Will the test be the same for those writing remotely? We may actually have a different test to ensure that we can implement this Proctorio software, but they will be on the same standard. My semester test 2 is next week, correct? The semester test 2, if you don't know, look at the learning guide. It's on the schedule for the 21st. Can't people just use their phones or another computer to cheat at home? While it's a little bit more difficult than that, we actually have specific software that locks down your computer and also make sure that we actually have a camera, so that if your eyes move away from the camera, that we actually know about that. So we have very strict requirements if you do want to write remotely. So the easiest is come to campus and come and write here. Okay, it's a lot less stressful. So if I got my password in VPL, I said, okay, no, just go and look on EVE. I mean, the passwords on VPL are actually published on EVE. So please follow the instructions on the video and you will actually be able to get your password from EVE. Okay, let's move on. I'm going to continue with our solution, and I'm going to share my desktop. So the objective of this evening is I'm just going to do a quick recap again of what is this thing called dynamic arrays, and I'm going to basically just discuss how we're going to handle the movement. So I'm just going to focus on the movement. I might not even complete the movement section, but we're going to discuss, before we do any bit of coding, potentially how we should approach this problem. So let's just quickly read through the whole movement. Actually, we should still do initialization. So yeah, maybe we should just talk about initialization first. All the characters are initially randomly placed anywhere in the environment. Okay, so we're going to do that. We are going to create a function that will help initialize our two-dimensional array, and then we're going to place our characters randomly in the environment. Now, the challenge with placing, we will look at this, but the challenge with placing things randomly in the environment, there are two approaches here. This approach, we actually have a fixed number of characters that we know. For instance, we have the total number of susceptible characters, the total number of recovering characters, and the total number of infected characters. We have that given to us through the command line arguments. So we have a fixed number of these characters which we're going to have to randomly place in the game world, and that's what we're going to do. But before we do that, let's just quickly do a quick recap again of what happens during initialization, specifically with dynamic arrays. And to help with that, I'm going to use my Microsoft Excel, and I'm going to try and describe what we're doing here. And maybe what I should do is let's first do some of the coding, and then I will explain to you what happens and how that can be visualized when you view that inside Excel. So I'm going to just go back to my VPL, and I'm going to create a function, because we're basically done with the whole command line argument. And what we've done is we've created a variable here, variable for the 2D array. Now let's just quickly see what happens as soon as you do this. As soon as you do this, inside your computer memory, something happens. And the best way to visualize this is think of it this way, that you will create a little box, and in that box, it will create that box as something special. So I'm going to just make a copy of that. I think the actual variable type is type 2 array. I'm just going to say here, type 2 array, and the variable name is array world. Boom, there we go. And as soon as you do that, a little box gets allocated in the memory of your computer. So there's my little box. There you go, allocated. But what is inside this box is still unknown. In fact, we know by looking at the specific type, if we actually go to the alias of this type, the way that we've actually declared the alias, we know that it is a pointer type here. And in fact, it is not just a simple pointer type, because this is a pointer type that will point to another pointer type, which will point to a number of integers. Okay, so it's a double pointer type, if you can think of it that way. So this little box basically means that there's a pointer in here. So let's get a little, oh no, that's not what I wanted to do. I actually wanted shape here, which is that thing. So I've got a little pointer, and currently that pointer points to some weird location in memory. Why? Because we haven't added any values inside that little box yet. Okay, so that's the only thing that happens as soon as you do this. Now let's continue with our function, and then we will see what happens after this. Now, the function that we're going to create will return a type2 array, and we will call it, let's say, init world, and we need the total number of rows, and we need the total number of columns, and we need, well, all of these things actually. We need to know the total number of infected, the total number of recovered, and the total number of immune people. So it's 3 extra integers. So it's int and int and int. Okay, so let's just say first this is the int total number of what was it, recovered, I think, and the other one is int total infected, and int total immune. emu. Right, semicolon, boom. This is what we call a prototype declaration. That means it basically describes what is going to be returned. It describes what the function name is, and it describes each of the different parameters that we will use in the function. So this function prototype basically says that it will return a two-dimensional array, basically a pointer to an integer. The function name is called init. Well, specifically the spelling init has 1, 2, 3, 4, 5 different integer parameters that we're going to use. So let's create that inside here. Right. Before we go on, let's just save. Let's build. Yeah, okay. I haven't used this for a while, you can see. Right. Remember, this obviously always happens, or can often happen when we use the VPL. Boom. Okay. No return statement in the function. Okay, so there's just a warning. That is perfectly fine. In fact, that is actually very good because there is no return statement, and we have to watch out for this warning. So when you create a function, well, any kind of function, and it returns something, and you're not very experienced at using functions, the best, I would say, rule of thumb is to always try and do the following. In your one of your first areas of lines of code, always declare some kind of variable. So I'm going to declare a variable here called array world, and then later on, I have to return array world. Array world. Why do I do this? Because it has to return this thing that I've said it will return. And for it to return that, I have to declare it, and I have to have this return keyword with the variable or the value of whatever that I'm going to have to return. And those are what I normally start with. All right, let's pause here. Let's see if there are any questions. I'm just going to quickly go back to questions. Okay. Is there a way for us to change our VPL password? I'm not sure. I don't think so. Marks to find. Okay, that's to find your VPL. Are we going to use Dia to create the UML and the design for semester test 2? I think we've discussed this, Mr. or Ms. Masinga. We will give you a paper, so bring your pen and pencils with, and you will actually do the design on the paper. So you're going to write out the design itself. Yeah, so you're basically going to draw it out with pen and paper, and we will take in your design paper as proof that you have written on site, that you were there and you were, and that's why if you for instance don't hand in a design or a paper with your details on, then we know you tried to write the semester test off site and you were not supposed to. Those students that has the remote permission, we will communicate with them separately on exactly how they will do their design. So, sir, the initialization function takes in all the parameters passed. Well, the initialization function takes in the parameters required to handle the initialization portion. Now, the initialization portion specifically says all characters are initially randomly placed. Okay, so that's why I don't worry too much about infection chance and recovery chance and those chances. But I need to know the number of people or the number of characters that I'm going to place, because that is what we have to do during initialization. Okay, so it depends on the initialization itself. Those are the parameters that I'm going to have to need. Okay, so what is cmd.txt? That is the command line arguments for the VPL. Yes, we've covered this last time as well. Will the design for online be written typed for semester? It will most likely be typed on a document if you're doing it remotely. So, sir, won't that screen of certificate always pop up when we are writing? It will pop up only once during the session, okay, not again. And if it pops up, you just accept it and you continue, all right? Next, let's move on. Okay, so we've started with this creation now. Now, the first thing that we have to do is when we work with a two-dimensional array is we have to allocate enough memory for it. Now, how do we go about doing that? Now, to do that, we're basically going to do the following type of instructions. And I will explain these instructions when inside the Excel little spreadsheet just now. So the first thing that we do is we're going to say array world, hey, little variable, you are going to get allocated some new memory. And the new memory that you're going to point to will be, guess what, a one-dimensional array of integers. So that type one-dimensional array of integers. And I explained to you just now, I'll explain to you in just a minute why we do this. And how many of them? Well, I'm going to need int rows of them. So just bear with me. I will explain to you just now what this does. But I'm also just going to quickly explain to you what happens after this. We haven't finished allocating our memory yet. We first have to now allocate the full two-dimensional array memory now. And for us to do that, I'm going to have to loop through each of the columns. So int column equals 0 while columns, each of the rows, so I have to go through each of the rows while the row is less than int rows. And I said, see there, that should be an R, and then R++. And then when you go through this, you're going to go to each individual, what we call pointer, or each individual item in the one-dimensional array, and you're going to create a new number of integers, space for a new number of integers. How many of them? Int columns. Okay, so let us stop here and figure out what happened. Let's just first look at this line of code. What does this thing do? This thing says, hey, Mr. Array World, go and allocate memory for int rows of one-dimensional arrays. What specifically does that one-dimensional arrays look like? Well, pointers to integers. So again, it's a special type of blocks. It can't hold any values. They themselves hold pointers as their storage. So what we're going to do here, let's assume I've got 3 rows. Now what's going to happen is, as soon as you've got that, 3 separate boxes gets created. So let's just do that, let's do that. 3 little boxes gets created, and then this pointer points to the first box. Now as soon as that happens, as soon as that new command, this thing is now what we call initialized. So there's a value inside my original array variable, and that value points to a box, and that box basically has 2 more boxes that's now been allocated to it. But these boxes are also special boxes. They're kind of like this box that we've created initially, because they themselves cannot hold any values. They themselves are individual pointers. So there's one, there's another one, and there's another one. And all of them are pointing all over the show at this point in time. That is what happens when this line of code runs. So can you see how many of those boxes did we create? Row numbers of them, int rows numbers of them. And obviously the new says go and allocate a few of these new boxes. So they are boxes that can point to integers. That's what type 1 array means. How do I know they can point to integers? Because it says it's a pointer type, which can point to an integer. Okay. Now, when we get to this portion, basically we're going to go into each of these little boxes that we've created. In fact, that's what we're doing here. We're saying, hey, box number 0, hey, box number 1, hey, box number 2. You are now going to point to a set of new boxes. How many of them? Well, column numbers of them. And what do you store in there? What type? Well, integer types will be stored in there. So let's see what happens inside Excel when that occurs. So as soon as that occurs and we run our first box, let's assume there's 4 columns. Then these 4 boxes gets allocated. And as soon as that happens, this little arrow now points there, and it changes color because it is now fully initialized, meaning there's now a valid value that's inside this little box. These boxes, obviously, they can store integers. I'm just going to put a little, let's put i's in there. I, and these are pointer types. So they have little p's that are stored in them. Okay, so that's now what happens after you ran this little for loop for one iteration, meaning we went to box number 0. Now let's go to box number 1 and do the same thing. We're also going to create new columns number of integers. So let's go and create. That's not what I wanted. Boom, and the pointer gets set, and the box is colored in. And then the last iteration runs. Boom, the pointer is set, and the box is colored in. And that is what happens when we allocate our memory. And that is why it is incorrect to say that, where's this code of mine? That array world, this variable, consists of a one-dimensional array and a two-dimensional. It's difficult to actually say it like that. Rather, from the start, say that, hey, you are the variable that will store a two-dimensional array. Why? Because that is exactly what this is. It is a two-dimensional. Remember, we said that array world, this array world variable is a type 2, meaning it's a pointer to an integer. Let's follow the logic. This is the initial pointer that points to a pointer that points to a number of integers. And that is why we have this double pointer when we declare array world. And we use the one-dimensional array of pointers to help us with the allocation of this section here, which is the array of pointers, to help us manage our two-dimensional array. Okay, so this is the allocation of memory. What values do we have in these boxes? Can you see it's all white? The values in there are junk. We don't really know what values are in there. We still have to go and initialize the values in them. There can be any kind of value in these boxes, okay, which is going to be our next phase. So let's just pause. Let's see if there's any questions at this point in time. Okay, let's go. Why is initialize function a pointer type? Because that's exactly what we're doing here. It is a two-dimensional arrays can only be created by pointer types. Okay, and I hope through my explanation now you understand why it is like that, because we are creating this pointer to a bunch of integers. Is there a chance of VPL freezing or crashing since there is going to be so many people accessing it at once? There is obviously a chance for that. That is why we're making use of double upload sessions. You're going to upload both on VPL and on Eve. If we do find that the VPL itself hangs, then we will fall back and you will just do your coding on code blocks and you will upload to Eve, just to Eve. All right. The return type for world is a pointer to a pointer. Yes, that is correct. Why isn't it a new array world type 2 array like int? Okay, so that's an interesting question. So why aren't we creating a type 2 array? Okay, so let's figure out this specific statement. Let's write it down and let's figure out what might have happened if we did this. So let's say, for instance, why is array world equals new type 1 array, and then we said how many of them? Int rows of them. Why is it that and not this? Type 2 array int rows. Okay, so let us first figure out again what is a type 2 array. Type 2 array, remember, is an int star star. Okay. Now how does it? Let's just color these things a little bit differently. Int star star means it looks like this first little yellow block that you see my mouse cursor is now hovering over. That means it is a pointer. It's going to point to a pointer that will point to a number of integers. Okay, so let's rather color it in red. All right. Let's have a look what is a one-dimensional array, or this alias type 1 array? That is just a pointer to a number of integers. So a pointer to a number of integers is that. Now, if we said new type 2 array, what would have happened was it would have created each of these little blocks as a red one. And then these pointers, they couldn't have been integers. They themselves must have been pointer types, which then should have pointed to some place. So basically, that should have been the same type as the initial red one, and then these ones would have been yellow ones, which then themselves had to point someplace. If these ones were of the same, if we try to initialize it this way. Okay, so hopefully that explains why we're creating, why this is the valid way of initializing the initial pointer, this set of yellow arrays, because they are just one-dimensional array, meaning pointers to integers. And not that, so that one is not valid. Let's go back. Is it a must to have a 1D pointer dynamic array when working with 2D pointers dynamic? Well, there's no other way that you can actually allocate enough memory. So you have to have that initial one-dimensional array of pointer types so that you can now go and allocate memory for the actual variables. There's no way that you can directly jump from here, from this red one, to automatically create this. Let's give it color. Let's make it green. This green array. Okay, let's try again. Okay, this green. It's impossible for this to immediately go there. It cannot do that. That's why we have to first create this intermediate little yellow array. Next. So on line 25, we say new double. Are we creating boxes of doubles? Did I create a double here? Where did I'm not sure I created a double. I think you probably must have missed something here. But no, I'm actually creating integers. But if you have created doubles, yes, then you will store, your two-dimensional array will store double variables. So if you, for instance, are just going to store a number of character variables, then you can make that character. You can make this, but now this is also very important. You have to then just change your alias as well. This int here must correspond to that type here. And remember, that type says it is a pointer to an integer. So you can't now suddenly change that. You have to, if you wanted to make it doubles, you have to do that as a double, and well, you have to do that as a double as well, and then you have to do that as a double. Double. All right. So hopefully that explains that portion of it. Let's just get this back. Int. All right. What was the other questions? Let's go. Oh, so the one-dimensional array allows dynamic arrays to be put into a 2D array. Is it difficult to make 2D dynamic arrays? Well, we've just done a 2D dynamic array. So we basically create a 2D array dynamically in memory. That's exactly what we did just now. We dynamically decided what is the total number of rows and the total number of columns. That's exactly what we did. Is it possible to write code on CodeBlocks during an exam, then copy? Yes, you may. Can you start by creating a 1D integer array of columns first, then set the number of rows to it? No. So I think what you're asking is, can you kind of reverse it? Can you create this first and then go back here? That's really difficult. It's probably possible, and I'll have to think about that, but it is a lot more difficult, I would think, to do it that way. So it might be possible. I'm not sure how you're going to work it into a for loop, though. And these values are not what they're going to be called anonymous variables, because that's or anonymous pointer types, because this is exactly what we're doing. This is called anonymous. Why is it anonymous? Because there's no name associated to these boxes. Okay, so there's no variable name. If you open that box, there's no sticker on it. The only box that has got a sticker on it is this original one, this red one. What is the sticker name? Array world, ARRWORLD. All these other boxes are what they call anonymous boxes. They don't have stickers on. The only way that we can access them is via this original red box that we have. But are we allowed to write the code on code blocks? Yes, we've done that. Okay, thanks. Okay, good. Right. Now, let's see if I actually didn't make some kind of mistake while I was coding this. I am. Okay, doesn't look like I made a mistake. Good, perfect. No errors, no nothing. Let's move on then. So this is how we will allocate the memory. Now, normally you will see that we can actually this step, this for loop, and put a little extra things in here if we want to create some default values inside our two-dimensional array. Because as soon as this line of code has run, that row's columns, meaning this specific row, has been allocated. So we can already start putting some values in here. And the way that you can do that is if you basically create a little for loop inside the initial for loop. So things like this, while C is less than int columns, go ahead and increment that, meaning we're actually going to go into each of those little blocks now. And then we can actually say, listen, row column, you are now going to have a value of, what did we say? Let's see what was called empty. Okay. So we're kind of short-circuiting our initialization of value. So we're not just allocating the memory, but also setting the initial values in the array. So that's what we're doing in this portion of the code. But that is not good enough. We actually have to comply with this requirement. So all characters are initially randomly placed anywhere in the environment. So that means I'm going to have to place all the, the infected characters. I have to go and place the immune characters. I have to go and place the recovered characters. Each of those characters will have to be placed randomly somewhere in the world, and I'm going to get some of that logic going here. So place the characters inside the same world. The first set of characters that I'm going to place is, let's take this recovering characters. So I'm going to say for int, I'm just going to use a counter variable here called n, while n is less than the total number of recovering characters. Go and increment through there and go and place the recovering characters. Okay, we'll worry about the logic. Can you see how I'm thinking? I'm not trying to get into too much detail now. I'm first trying to get some of the, let's call it the overall logic figured out first. And then I'm going to worry about this detail about how do we actually place characters. So next set of loops will be for the infected characters. So bad guys. There's a fly that just sat on my nose. And boom, and then place the infected characters. Then we're going to create another loop here for the total number of immune characters. Or something like that, I can't remember. It's the immune characters. Is it immune? Let me just confirm that that is in fact infecting chance, recovery chance, immune. And the initial number of characters. We said that that is recovered, infected. Oh, and susceptible. Oh, that's not right. It should be susceptible. Susceptible, recovered, and infected. Okay, I'm just going to have to change. I'm going to change my immune to susceptible. So let's just fix that. I thought the immune thing only comes in a little bit later. So let's say susceptible. So let's just quickly go and update. Yeah, I know my other immune. Let's make that susceptible. Let's change it in my prototype as well. And I just want to make sure that this is how I got. See, I made a mistake here as well. Susceptible. There we go. Total recover. Total susceptible. So there was a mistake here. Susceptible. I think that's something like that spelling. If it's not correct, I'm not worried about it now. So that's the total susceptible. Total susceptible. I think that should be it. Let's see if it's now fixed everywhere. Okay, it doesn't look like, looks like I've got everything fixed. Yep. Okay, so before we continue, this is the, for those watching the late recording, this is the code for the late recording viewers, QLL 884B as in Benny. QLL 884B. Thank you very much. So we've got a little bit less than 10 minutes left. We've got about 7 minutes left for this. And we are going to now focus on this section. Place the, well, how do we randomly place these characters? Now, let's go back to the drawing board and figure out how we can achieve this. So let's assume we've got a two-dimensional array. So here it is. Forget about this one here at the bottom. And we have 3 characters to place. Forget about the type of character to place. What we will do is we will loop through the number of 3, and for each of these loops, what we need is a random location. So random location. And what is a random location? Well, it is a random row and it is a random column. So random row, random column. How many rows do I have to choose from? Between 0 and 2, that will give me some kind of random row, and between 0 and 3 will give me a random column. Now I'm just going to, for now, just use Excel, land between 0 and 2, I think, and rand. We'll worry about the C++ stuff just now. But first talk about the logic behind this. That's interesting. Why is it not changing values? Oh, there we go. Okay, so it does change. All right, so what's going to happen is in the first iteration, while we're counting, so n has a value of 0, we're going to generate a random row and column, 1.1. Okay, so we're going to go to 1.1. Before we can place anything there, we want to make sure, is that location empty? If that location is not empty, we're not going to place one character on top of the other. That will go against the whole rules of the semester test and the exam and so forth. So we first want to make sure, is that location empty? If the location is empty, we're going to place a character. And then we're going to update our counter. Okay, and then we're going to generate a new row and column. That's 2.2. So we're going to place another guy there. And then, okay, let's say, for instance, we're already at n is equal to 2, and we again, let's assume we got the same location, 1.1. Oh my goodness, it's not empty. Well, as long as it's not empty, I'm going to have to again generate a new random location. And I will keep on generating a new random location until the location is empty. And once I get a location that is empty, let's say 0, 3, then I'm going to place the character in that location. Okay, so I'm going to create a little function that will help me for this, do this. So I'm going to create a little function that will randomly generate a location I will look at the location once it's generated, and I will see if it is empty. If it's not empty, I will again generate a random location, and I will again evaluate, is it now empty? If it's still not, I'm going to continuously do it until I get an empty location, and only then will I place the actual character. And I'm going to do that for the number of characters that I need. And that's how I'm going to solve this portion. So let's just pause for now. No, let's get that quickly in. And I'm going to do this by using a function here. And this function itself is not going to return anything. I'm just going to say place feature. And it will take in, obviously, my two-dimensional array. Because I have to place these characters somewhere. I need to know the total number of rows and columns so that I can get some random number. And I need to know the actual feature that I want to put in. Because remember, each of our values in my two-dimensional array in this example are integer types. So for the, where is it here? For the susceptible, I've got a value of 1. For the recovered, I've got a value of 2. For the infected, I've got a value of 3, and so forth and so forth. So I'm going to just, by using these values, I know exactly, well, I'm just going to pass it in, and I'm just going to place it. All right, so let's get this going. So I'm just going to write the logic here. We're not going to have enough time to actually go through the write all the code, but generate a random location. Then, while the random location is not empty, generate a new random location. Then eventually I will place the feature in the random location. All right, the reason why I'm not going to do the code for this right now is because we're using this word called random, and I'm going to have to do this quite a few times. So I'd rather create another function here that will help us do random number generation. In fact, we have time to actually go do that. So this one is a fairly simple function. The function will always return some kind of integer. And the function name, I'm going to call mine getRand, and it takes in 2 parameters, some kind of lower parameter and an upper parameter. So it will always generate a random number in between these 2 values. In fact, and it will include these 2 values. Now, the way that this is done is we generate a random, or we start with some kind of a variable called range. It's not really a range, but it helps to define the total scope of potential random numbers, or total number of potential numbers that we need. And this scope is the int upper minus int lower plus 1. That will generate the scope of the range. And then this will return, using the rand function. The rand function generates a random number between 0 and I think 65,500 or whatever. It's a really big number. Now, to ensure that really big number fits inside this range, we use this modulus operator. So modulus in range, and then this modulus operator will generate random numbers between 0 and whatever this range is. And for us to ensure that it's actually shifted into the proper range itself, we have to just add int lower to that number that was generated. And that is typically the function to generate a random number. But because we're using this rand function, as soon as we do this, we have to make use of srand. And srand is always recommended to only have it once at the top of your main function. And this will seed the random number generator. And the way that we seed it is by using the srand function, giving it the time function using a null pointer parameter. So basically, time null pointer returns the current time. That number is given to the srand function, which then helps to generate a random number sequence And that random number sequence is then used by this random function. Okay, so that's as far as how I want to take it today. Ladies and gentlemen, I'm going to stop the recording. I will manage some questions till afterwards, but my next class basically starts in a few minutes. I'm not going to be able to get spend too much time answering questions. Let's have a look. Okay, Mr. Shibam. Okay, then you are semantic. Okay, please show how I can figure out where I went wrong during my coding if the program isn't doing well. Okay, this is so many questions. It is interesting that deallocation of the memory to delete the array is almost the exact reverse process working from. You're 100% correct. So we still have to do the deallocation. Sir, can you please upload this code on Eve after the sessions? Okay, I will download the session just now and the code and upload it, but after my next class. I won't have enough time before the next class, so can you show how I can figure out? Please have a look. Last week's, not the last week's tutorial, the week before that, I actually made a mistake during the tutorial video, and I basically followed. I created little breadcrumbs to figure out where I went wrong. So, Mr. Singo, look at not last week's tutorial, the week before that I uploaded onto Eve, or the link published on Eve. So please have a look at that. That will help you. So, sir, will I be wrong for creating a nested for loops inside the first for loop? I have created the first for loop. Then you are semantic errors. So explain. You see out statements. Okay, that was correct. If we were to work with more than one to the array, would it be smarter to rather allocate memory helper function? Absolutely, I would do that. So, Mr. Omar, I will definitely do that. In fact, I will probably make a change in my code to have a separate function to do the allocation, because I'm going to, even in this solution, I'm going to have to create multiple two-dimensional arrays still. Right. Thank you very much. So, why are we creating outputting characters? Because we can play around with these numbers, specifically if you want to evaluate things like health. It's difficult to do that using just character values. So when we're calling a random function in the feature that requires, for example, to be placed randomly only in the first 3 rows and columns, so will we just adjust the rand function when we call it? No, that is a different logic. So Mr. Omar, there's a different logic to trying to only work with a specific portion of your 2D array. Normally, for that, you will loop through the 2D array, and then you will generate a random value to determine if a variable should be placed in that location or not. So there's a little bit of a, oh, no, but I'm sorry, Mr. Omar, you are 100% correct. You will basically limit the random values to only include, let's say, from 0 to 2, if you only want worried about the first 3 rows or columns. You're 100% correct, sorry. Why is it some other functions create even when they are not called in the .h function? .h function, or the .h, the prototypes, is exposed to the rest of the world. If you're not going to require that function to be available in the main function, then it's not necessary to actually declare them in the .h function. Yes, thank you, Mr. Omar. Ms. Omar, can you confirm? Made my prac take like 10 seconds to start up last week because I put it in getRan. Okay, I'm not sure about what you're saying there. I'm running out of time. Guys, I have to leave, unfortunately. I'm not going to be able to go through all of the questions. So sorry about that, but my next lecture